Alright class, last time I gave you a take-home problem, and your take-home problem was that figure out the quantum numbers for potassium and for phosphorus. That was your take-home problem. Okay, in order to figure out the quantum number for potassium and phosphorus, you should do electron configuration. That's the first thing you should do. And you can do abbreviated electron configuration. That should be okay. Abbreviated electron configuration for potassium, the last noble gas is argon, and then after that is 4s1. Okay. Now, the last orbital is 4s1. That is my last orbital. And we said that to do quantum numbers is for the last electron you put down. So here is my last orbital. And if you look at this orbital, it's an s orbital. S orbital, we only have one s orbital. S orbital has only one room. And this is 4s. Now, how many electrons is in here? There is one electron in 4s. Again, 4s, the fourth level, s orbital. S orbital has only one room and one electron. And this is one electron. One electron, one electron. Now, remember what we said. Quantum numbers are n, l, m sub l, and m sub s in this order. Okay. What is my n? My n is 4. My n is 4 because we're on the fourth level. Now, if you remember, we said the L means, what does the L mean? The L, which is the shape, means is it S, is it P, is it D, or is it F? But because quantum numbers have to be numbers, what we do, we assign a number to S, P, D, and F. We are assigning a number to all of them. In this case, we are in an s orbital, and s orbital is 0. Again, we have to just assign a number to them because quantum numbers have to be numbers. M sub L, which is the orientation. M sub L is the orientation. And if you remember, this would be 0, right? Because again, we have to assign a number to it. M sub L, this is the orientation, and is 0 because when you have a s orbital is spherical, when you have a round object, there is only one possible orientation for the s orbital. So that would be 0. Now, m sub s, that's the spin. Is this one up or is this one down? This one is up. If you're up, you're plus half. And if you are down, you're minus half. So this is up, I'm going to be plus half. This is a quantum number for potassium. Okay, let's do the next one. The more practice we do, the better you're going to get at this. The next one I ask you to do quantum number for phosphorus. Again, what I'm going to do, the first thing I'm going to write down the abbreviated electron configuration. Now, if you didn't get the potassium right, but now you know how to do it, redo the phosphorus. Pause me, redo the phosphorus, and then check your answer with me. So, last noble gas is neon. From that is 3s2, 3p3. Those are my quantum. Those are my electron configuration, abbreviated electron configuration. And remember what we said. What we said was that quantum numbers are in order would be n, l, m sub l, and m sub s. Okay. Now here is our last orbital. Here is our last orbital. Our last orbital is p. Our last orbital is p. Now, how many p orbitals do we have? We have 3 p orbitals. 1, 2, 3. P orbital has 3 rooms. Now, 0 plus 1 minus 1, because we have to put numbers for everything. Now, how many electrons does it have? It has 3 electrons. Where do I get that? 3p3. It has 3 electrons. It has 3 electrons. So what I'm going to put 1, 2, 3. Okay, so this is the last electrons I put down. Now, remember, this is a 3p. Let's do this together. What is the n value? We are on the third level. We are on the third level. What is the L? What is the L? Well, you already know that. The L is the P, and P is 1, right? S is 0, P is 1. So we're in a P orbital, and we assign 1 for the P orbital. So L would be 1. Now, M sub L, again, M sub L is the orientation. Again, it has to do with this one, is in this room, +1. It has a +1. Here's the orientation. Where is it pointing? And M sub S, is this up or is this down? If you look at it, this is up. If you're up, you would be +½ If you're up, you would be +½ Okay, so my quantum numbers are 3, 1, 1, and +½ Those are my quantum numbers. Okay, nice job so far. Now, the next thing I'm going to talk about, two definition, paramagnetic and dimagnetic. Again, it's same chapter, we're still doing the same stuff. Paramagnetic means at least you have one unpaired electron. At least you have one unpaired electron. So you know how like we had the electrons that was going up and down? That means it's unpaired. It doesn't have another pair next to it. And if you have at least one unpaired electron, what that means is it will interact strongly with a magnetic field. Now, what do you think dimagnetic is? Dimagnetic, what it means is everything has to be paired. So all the electrons are paired electrons. So every electron has a pair next to it. The spin, they have one pair next to it. So they cancel each other out. And because they cancel each other out, they interact weakly. With a magnetic field. They interact weakly with a magnetic field. Okay. Now, let's go look at the last two problems that we did. Potassium and phosphorus. Are potassium and phosphorus paramagnetic or dimagnetic? Let's go back. What do you guys think? Potassium. Is potassium paramagnetic or dimagnetic? This is unpaired, right? At least you have, as long as you have at least one unpaired electron, you're paramagnetic. So potassium will be paramagnetic. How about phosphorus? Unpaired. These are unpaired electrons. So phosphorus is also paramagnetic. So potassium and phosphorus are both paramagnetic. Again, as long as you have at least one unpaired electron, you're going to become paramagnetic. Alright, so far so good. Now, what I'm going to do, I'm actually going to end this lecture here, but I'm going to give you a take-home problem to do. Yeah, you thought since we've gone online, you're done with take-home problem. I mean, you're already at home. Maybe I should come up with a better name for take-home problem. Alright, ready for a take-home problem? Here's what I want you to do. For uranium, the element uranium, what I want you to do, I want you to write down abbreviated electron configuration. I want you to write down the NLX notation. I want you to write down the quantum numbers. And the last thing, is it para or diamagnetic? And if it's para, how many unpaired electrons? If para, how many unpaired electrons? Sounds good? Okay, before you watch my next video, please make sure you do this. This is a good problem. It kind of reviews everything we've talked about so far. Alright guys, take care. I'll see you soon. I talk to you soon.